Well, welcome everyone to another Topsoil webinar. As you guys can tell, I am not your usual host, Mitchell. My name is Carolyn King, and I am the Vice President of Operations here at Continuum Ag. And I have a very special guest with me here today. I've got Dr. Liz Haney. Liz is a very good friend of mine, and we'll let her kind of introduce herself in just a second. But to get things kicked off here. Who is Continuum Ag? Continuum is a soil health data management company. We're on a mission to help 1 million farmers improve their profitability by improving their soil health. And there's a few different ways that we do that. Most of you probably know us from CI certification, CI scoring, 45Z, but for a long time, we've also been in the regenerative consulting and soil health testing space. And that's where our guest Liz today comes into play. So Liz is a soil scientist and ecologist, and my favorite fun fact about Liz is that in high school she was voted most likely to run a roadside vegetable stand. I feel like that's very fitting and a good way to introduce her. So Liz, why don't you, besides that, give us a little background on who you are?
Yeah. So I have a bachelor's degree in wildlife fisheries science, a master's in soil science, and a PhD in ecosystem science. I've worked in several different fields, including surface coal mine reclamation. I worked for a carbon company for a while. We don't like to talk about that much, no. Uh, but now my business partner Russell Hedrick and I have Soil Region. We've been operating for about 5 years now, and what we do is help farmers do farm planning, transition to regenerative agriculture methods from conventional methods. We also help companies run research trials and get meaningful data to prove out their products. So that's pretty much me in a nutshell.
Cool. All right, well, today we are going to do a deep dive on the Haney test. So we'll talk a little bit about the history of the test, and how it got to where it is today. And then we'll dive into some of the key parameters. And then we'll focus on how to reduce fertilizer applications by using these results. I'm sure that's top of mind for a lot of people right now as we start to move into the growing season. So we'll spend some time on that for sure as well. If you have any questions, please make sure to put them in the chat. We will run through them as they come up, and then we'll make sure to leave some time at the end to wrap any of those up. So make sure to throw your questions in the chat. Okay, so let's just start from the very beginning with the history of the Haney test. Liz, run us through like why was the test created? Where did the idea come from, and how has it evolved to get us to the point that we're at today?
Yeah, so my husband Rick was a farmhand for a very long time. He worked for his family and then also for one of our now best friends growing up. And he just saw producers losing money, not being able to reduce fertility inputs, basically being in the hand of the commodity and agrochemical grip, I would say. So he went back to school and started studying soil biology. He studied microbiology, and he started investigating CO2 respiration, so microbial activity, and then did a lot of different studies to relate that to nitrogen mineralization. So the Haney test started out as a more comprehensive way to make fertility recommendations. And the soil health aspect didn't come along until much later. And so all of the parameters together do the soil can tell us how your soil health is, but also help us to make more accurate fertility recommendations.
Yeah. I feel like those two things are, I mean, obviously the whole foundation of the test, but also the most important part to understand together. And we'll talk a little bit about how it's different from standard soil tests. But the key thing to me is that the Haney test is looking at the biological piece and how the biology influences the chemical piece and the nutrients. So we're actually looking at it as a whole picture instead of two completely separate things like they don't interact at all.
That's right.
So let's talk a little bit about standard soil testing. Like, run us through soil tests that most people are familiar with. Like, how do they work? How did we end up with those? And then why is it important for us to maybe shift our mindset a little bit into using something like the Haney test?
Yeah. So when I went to school to get my master's, I was taught about soil mineralogy, chemical reactions in the soil, how to make fertilizer recommendations, a lot of soil chemistry. And soil biology wasn't a part of really any program that they had at my university. So I went to Texas A&M, land grant university. And standard soil tests were developed between the 1940s and 1980s, pretty much. They use harsh chemical extracts that aren't actually seen in the field or in the soil to estimate basically yield response to fertilizer applied. So what we want to do is study what your soil sees in the field, what your plants are seeing in the field as your crop is growing. Um, so standard tests, because it's an estimate, it's really led to the over application of nutrients, which can hurt your return on investment. As many know, land grant universities are often funded by big agriculture companies. So, the research is kind of hard to push forward going towards more biological amendments, biological fertility, nutrient cycling. And so this has kind of been a 25-year struggle to get the Haney test up in front of people.
Yeah, I had the same exact experience, except not at Texas A&M. I went to Iowa State, got my bachelor's and master's degrees in agronomy, and same thing. Like, we didn't even talk about soil biology. It was a super small blip that, maybe one lecture covered it. But we definitely did not discuss like how biological interactions really influence a lot of these things. So, someone once said to me that soil without biology is just geology, and that definitely resonated. Like, if we don't focus on the biological piece, then we're just talking about rocks. So,
Yesterday, I gave a talk to some kind of a different crowd, forestry people. And I was really surprised. The first thing they asked me when I walked in, they said, "So you're the soil lady, right?" I said, "Yes." And they were like, "So pretty much our land grant universities don't care about us at all, do they?" And I was like, "Well, I wouldn't say it quite that way, but yeah,
yeah,
we're stuck in the mud here, pretty much."
for sure. Okay, so we talked about traditional soil testing, but let's go over how is the Haney test different from these standard soil testing methods?
Yeah, so we use different extractants, and traditional soil tests ignore biological influence. So they only measure inorganic nitrogen, phosphorus, potassium, and micronutrients. Right now, Malic 3 is being touted as a universal soil extractant. It has a pH when it hits the soil about 2, which is hopefully not what our soils are actually seeing. So we use different extracts such as water and H3A, which is organic acids that your soil actually sees. So we want to extract nutrients in your environment under your conditions. We quantify biology by measuring CO2 respiration. So microbes take in oxygen and give off CO2 like we do. There are about 70 participants in here. If we were all in the room together, the CO2 level of that room would raise, just like if we have more microbial activity, the CO2 respiration is going to be increased. And then we measure organic and inorganic forms of nitrogen and phosphorus, which is adding to plant available nutrients that we weren't seeing before.
Yeah, so can you explain how does the CO2 respiration get measured at the lab? Like, what's that process look
Yeah.
like?
Yeah. So when soils go to the laboratory, all soils, no matter what test you're running, they get dried and ground to a consistent, like 2 millimeter sieve. Anyway, they're consistent. So they get dried and ground. We take 40 grams of that soil, put it in a cup that has holes in the bottom of it, a plastic cup with filter paper there so the soil doesn't fall through. They put it in a mason jar, very technical here, but it actually is technical. Put it in that jar and put some water in there and let the soil re-wet to field capacity. Then it is capped off, kept at a consistent temperature for 24 hours. And while it's being capped off, CO2 is respired and trapped in that jar. And then the laboratory uses an infrared gas analyzer to measure how much carbon dioxide is involved in those 24 hours. And our research has shown over and over that CO2 evolution is directly correlated or directly relatable to nitrogen mineralization. So microbes chew on carbon that's associated with nitrogen, and then they release that nitrogen to the plant. So the more microbial activity, the more CO2 that we measure in the lab, the greater your chances are for nutrient cycle.
Yeah. I think the key things with that, like I always explain it to people as that drying and re-wetting effect in the soil is like crucial for nutrient mobility. And it's because the biological activity is changing as the drying and re-wetting cycle happens. So
Which
surprise,
naturally
surprise,
happens.
water is important.
Yeah.
Yeah,
And it rains water. So
exactly. Yep. Cool. Okay, let's talk a little bit more about the extract that's used. So you had mentioned H3A a little bit, but let's dig into like what is H3A? How is it different? Why does it make sense to use it?
okay. So H3A is citric, oxalic, and malic acid. It mimics plant root exudates. And so plants take in carbon dioxide from the air and they pump out carbon and they pump out to feed microbes. They also pump out organic acids to slightly modify the pH around that rhizosphere and solubilize nutrients. And so we're trying to mimic that process that happens in the field in the laboratory. H3A is not buffered, so it takes on the pH of your soil instead of taking it down to a pH 1 or pH 2. We want to mimic what your soil's actually seeing. When we lower that pH level the way that common extractants do, we're going to solubilize things that aren't really plant available. So if you have a high pH soil, we would be solubilizing calcium phosphates, which aren't readily plant available. Or if you have a low pH soil, we might be solubilizing iron and aluminum phosphates, which are also not plant available. The way that standard soil tests are calibrated is by doing a yield response. And so it's basically a proxy for measuring how a corn plant is going to respond in a conventionally managed field on a 5 foot by 10 foot plot when we put fertilizer there. But what we're trying to see with the H3A extract is what is happening when your plants are growing and how are they pulling nutrients up into the rhizosphere and up into their roots so that they can grow.
Yeah. Yeah, so we're actually trying to mimic what's happening in the soil instead of using something that's creating an environment that doesn't even exist in nature.
Yes.
Yeah, cool. Okay, so we're going to shift and dive into just digging into some of the actual parameters. As a reminder, if you guys have any questions, please put them in the chat. We'll kind of take them as we go and then hit the rest of them here at the end. But this is what a Haney test looks like when it comes back from the lab. Our preferred lab here at Continuum, same with Liz and Soil Regen, is Regen Ag Lab in Nebraska. And this is what their results look like. So we're going to
Oh,
hit,
disclaimer here.
oh yeah, good call.
Yeah. So even though it's called the Haney Soil Health Test, um, neither Rick nor I make money off of the Haney Test. We have jobs that we do that we make money from, and then we also do not own the laboratory.
Yep.
Just want to
And
set
yeah,
that.
Continuum Ag also like not an owner in the lab. We just know and trust Lance that runs it and the whole crew. And we know that they're doing the test the way that it was intended to be run. So that's who we choose to work with. But yeah, Lance unfortunately doesn't send any of us a check to talk about it.
No, we have
Maybe someday.
to.
Yeah. Cool. Okay, so there's a ton of parameters on the Haney test when it comes back from the lab. We don't have time to dig into all of them today. We're just going to focus on a few key sections that are really important for getting to those fertilizer recommendations. And the first piece of that is, of course, the soil health section. So here's a smaller snippet of what that looks like. And then I also have below the table a list of the ranges that we would like to see each of these parameters at. These are not like requirements. These are just guidelines based on all of the soil samples that we have run with some guidance from Rick and Liz to make sure that they make sense. So if you're looking at a Haney test, if you've got some results in front of you and they don't exactly match what we're showing here, it's not the end of the world. These are just some baseline numbers to get you started. So in the soil health section, we have a bunch of parameters. Liz,
Can I
where do you
stop?
want
Can
to
I say
start?
something there? Like,
Yeah,
really don't compare yourselves
right.
because it's not. We're not in a locker room. This is what's happening in New Mexico or Eastern Colorado, Western Kansas, where it's really, really dry. A really, really good CO2 respiration number might be above 30.
Hmm.
If you're in Iowa with, 6 foot deep black soil and your respiration is 30, you're doing something
That's
wrong.
right.
So it's all context dependent and it's year over year dependent. If you're in a drought or you've been waterlogged, like we've seen, Carolyn and I have been up in Minnesota a lot the past couple of years, it looked like they were flood irrigating corn. You're not going to get CO2 respirations numbers that are very good under those conditions. The year before that, it was completely dry, same situation. So it's all contextual. Biology changes all the time, every day, throughout the day, and throughout the year. And I think that's why some people have a hard time with this test because it's not black and white. Biology is not black and white. It's always cycling, it's always moving, it's always changing.
Yeah. Yeah. Context is definitely the most important part. Even if you're comparing some samples you have from last year to samples from this year and you're like trying to understand why some numbers are very different, definitely the place to start is by thinking about like what were the soil conditions? Was it wet? Was it dry? Was it hot? Um, all of those pieces are critical to understanding this. So. Okay, let's just dig into each of these. And Liz, we can kind of start with whichever you want. We've talked about the soil respiration or the CO2C a little bit, but I think we should hit on that again. Just what does that parameter mean? What are some instances when we would see it really low or really high? Like kind of where do we want it to be? Let's just run through all of these and kind of talk about each of them.
So when we ask people to, when people ask us, when to take a soil test, a Haney soil test, um, we say with temperatures above 50 degrees, not air temperature, but soil temperature. And the reason for that is because soil respiration is dependent upon temperature. So in the winter, things kind of die down, not here in Texas, but up where Carolyn is for sure. It's cold. Microbes don't like that very much. And a lot of them hunker down. Some of them die when it gets warmer in the spring and we start getting water that's available. They jump back into action. The pool party's open and they're active. So CO2 respiration numbers are going to vary with that. Above 50 part per million is good. 89 on this example is very good as well. But it's going to change throughout the year, and I really want to stress that. I've had producers take samples in the fall right after they've planted a cover crop, and the respiration numbers are a little bit low. The water extractable organic carbon numbers are a little bit low. And then they go through winter, and in the spring, as the plants start growing, as their cover crop starts growing, they're pumping in food sources for those microbes. So the microbes become more active. The temperature helps the microbes become more active. Everything springs into life. And so you can see it change throughout the season. And I can't remember what you asked me to say. I got lost.
No, that was good. And Craig had actually asked in the Q&A, how does soil temperature affect the results? So
Yeah.
it's exactly what you just said. As the soil temperature increases, the biological activity is going to increase, the water extractable organic carbon will increase as you've got plants out there that are growing and pumping that weoc down into the soil. So yeah, soil temperature is a big one. And I think you mentioned, but we don't want a soil test below 50 degrees. That's when the soil biology really slows down, and we won't be able to credit as much from the nutrients because of that.
Or when it's too hot, which
Yeah.
again, in Texas, I have gone out and taken a sample and when the soil temp was above 100 degrees, and they don't like that.
Yeah.
It's going to give you basically a false reading.
Hmm. Yeah. Okay. Water
Also, when
extract.
it
Oh, go ahead.
tell them about when it's waterlogged or too dry as well.
Yeah. Same exact thing. The biology just is not happy in those situations, and so you'll get a false reading or really low reading that we just know is not reliable.
Yeah.
Okay, water extractable organic carbon. We've mentioned it a couple times, but definitely have not dug into it yet. So, what is WEOC? Why do we use water to measure it? How are we using it throughout the rest of the test to understand all of these other parameters?
Okay, so microbes live in aquatic films around aggregates and within pore spaces. They need water to live just like we do. And what they see and what they feed on is water extractable organic carbon. So these are small, short chain carbons that are part of the active biology in turning. It's a much, much smaller pool than the total soil organic matter. Microbes can act upon that as well, but they will first go after this water extractable organic carbon. And so microbes need carbon and they need nitrogen and other things in order to build their population. They prefer, well, I'll go into carbon and nitrogen ratio in a little bit, but when they chew on this water extractable organic carbon, they release nutrients back to the plant. And so, again, all microbes care about is reproduction. They want to build their community. And so they act upon that water extractable portion that's the readily available one that's right next to them where they're living.
Yeah, and the readily available piece is key for the water extract part. So we mentioned earlier, but it rains water. It doesn't rain anything else. It just rains water. And so using water as an extract for carbon and organic carbon and organic nitrogen is key so that we can understand what the biology is actually seeing. What about microbial active carbon percent MAC?
Okay, so percent MAC is a measure of how much your microbes like the carbon in the soil is one way to look at it. Another way to look at it is there enough food source available for the microbes? And if not, if there is and they're not being active, what's the reason for that? So above 50% is good. It's really just a ratio of respiration versus water extractable organic carbon. But when we have percent MAC numbers, let's say below 50%, you have enough food source, but really low respiration, we can determine that there might be problems with the soil, such as compaction, um, toxicity due to too much phosphorus, or toxicity due to too much aluminum. The soil's not in balance. The carbon to nitrogen ratio is not in balance. There's different reasons why your percent MAC could be low. When your percent MAC gets really, really high, that means that, and I'm saying over 100, 120%, which actually happens, your microbes are turning through carbon super fast. They're super active, and we need to keep pumping carbon into the system to keep them going. So we need to keep feeding them. It's like having teenagers at a dance party and they all get exhausted and you stop giving them food. Then they're going to go home. So we want to keep pizza coming. We want to keep that water extractable organic carbon coming.
I love that. That's a good analogy. So the CO2C is the biological activity, the WEOC is the microbe food, and then the percent MAC is essentially how much do your microbes like your food, or do they have enough of it?
Yeah.
Okay, C to N ratio. We have not talked about organic nitrogen yet. That's in a couple slides here, but give us a high level, what is the C to N ratio? Why should we care?
Okay. So water extractable organic carbon is not just carbon floating by itself. Attached to it is water extractable organic nitrogen. And we'll probably talk about that a little bit more later. But the carbon to nitrogen ratio that we measure with the Haney test is not total carbon and total nitrogen, it's the water extractable portion. And it's important because that's what the microbes say. So microbes want a carbon to nitrogen ratio, or they have in their bodies between 15 and 1 and 20 to 1. We want the soil to be between probably 12 and 18 carbon to nitrogen ratio in a cropping system. It's going to be different for grasslands or things like that. Native grasslands typically have a carbon to nitrogen ratio of around 20. But we want to keep this carbon to nitrogen ratio in balance so that they don't steal carbon from your soil aggregates. So if your carbon to nitrogen ratio gets too low, you don't have enough carbon to feed them, they're going to find that carbon elsewhere. If your carbon to nitrogen ratio is too high, they're going to need more nitrogen. And what microbes are going to do is they're going to immobilize nitrogen, steal it from your plant so that they can have it in their bodies to grow their population. When we make cover crop recommendations, we look at percent MAC, how fast you're burning through carbon. We look at carbon to nitrogen ratios. So this has a percent MAC of about 70. It's got a carbon to nitrogen ratio of about 9. The cover crop suggestion says 10% legume, 90% grass. That means 10% legumes and brassicas. But the reason that it's putting such a high percentage in the grass part is because grasses have a higher C to N ratio. We have a pretty good MAC here. We have a low carbon to nitrogen ratio. We want to keep building that carbon up. And so we can do that through cover crops. We can also do it through biological additions or manure additions, compost, those kinds of things. But we want to keep everything in balance. And that's part of what makes this test a little bit harder to interpret sometimes. But it's important to keep it in balance. And so we're looking at all of the different parameters trying to make your microbes happy so that they cycle nutrients for you.
Excellent segue into the soil health calculation. So looking at all of these parameters together is how we end up with this soil health calculation. Tell us a little bit about what that is, how is it calculated, and what we should use it for.
So the soil health calculation takes into account respiration, water extractable organic carbon, and water extractable organic nitrogen. And off the top of my head, I can't remember how it's calculated. Um, but above a number 7 is good. As time has gone on and we get more and more producers doing this test and doing more and more regenerative methods, I think 7, like she has here, fine. It's fine. I would go up a little bit higher, but it's more important to look at that and see your progress over time, a 5-year trend or something like that, and not look at your neighbor's soil health calculation versus yours. Unless they're conventional, it's going to be crap, so you're fine.
Then you'll
But
feel great.
yeah, um, but it's just gives you a general scoring on, kind of where you're at and where you need to go. I generally don't spend a lot of time focusing on it, except for when I'm looking at trends year over year.
Yeah. Yeah, that's how we like to use it too. Similar to increases in organic matter, we know that increases in the soil health calculation over time mean that we're headed in the right direction. So we like to baseline it and then look at it each year and make sure that it's going up. It's also a good one if you're comparing, like you mentioned, conventional. If you're comparing like two cropping systems, maybe you've got a field that is conventional, no cover crop, but you're also trying cover crops on the field right next door. That soil health calculation can be a really good one to use to just like very easily understand how biologically healthy is the soil. Okay, so that is the soil health calculation. Next, we're going to talk about nitrogen. Liz, tell us. So there's a lot on this slide. The nitrogen section is huge. I think it's the biggest section with phosphorus being the second biggest. So tell us just overall, like we've got some parameters with the H3A extract. We've got some parameters with the water extract. Why are we looking at so many of these and why are we looking at them with two different extraction methods? And then we can dig into which ones are the most important to focus on.
Yeah. So if you were to send a sample to, let's say, a university and laboratory, well, some of them, you would get nitrate nitrogen only back. And they use that nitrate nitrogen to make fertility recommendations. But that's not all that is available to the plants in the soil. So we look at nitrate nitrogen and ammonium using the H3A extract. Those two together make up your inorganic nitrogen pool. In this example, we have 58.4 part per million inorganic nitrogen. That's quite a
That
bit of a
is
lot.
super high, yeah.
I would feel like this was recently fertilized.
Yep.
Yeah. We can see when you fertilize and when you haven't. It's just like Santa, when you've been good and when you haven't.
That's right.
Yeah. So then we use water to measure total nitrogen, because again, your soil sees, water. And we take that total and subtract the inorganic nitrogen from it to see how much organic nitrogen you have. So organic nitrogen can either be mineralized by microbes into inorganic nitrogen forms, but plants can also take up organic nitrogen. The organic nitrogen consists of amino acids, different things like that. It's completely different than SLAN, though, if anybody's ever run that. SLAN numbers are typically 5 to 6 times higher, and all of that is not plant available as compared to water extractable organic nitrogen. Then the column next to that, we have an organic nitrogen to inorganic nitrogen ratio. I like for that ratio to be above 1. And the reason is because nitrate nitrogen is readily leachable. So anytime it rains, you're going to lose nitrate down into the soil profile or into groundwater. Or, in drier conditions, you might have ammonia volatilization, depending on the pH soil, and you can lose that pretty easily too. But organic nitrogen stays put until the microbes act upon it or until the plant takes it up. And so I like that number to be higher. When I see really, really healthy soils, I've seen organic nitrogen to inorganic nitrogen ratios above 3 or 5. It doesn't happen all the time, but I do see that, especially in like pasture systems. The column next to that is organic nitrogen release. Organic nitrogen release is based on microbial activity. So if you have organic nitrogen in the soil, but your microbes aren't active, we're not going to give you credit for that potential mineralization because we don't want to shortfall you in any way. It might become available later as your microbial activity increases. And in that case, we would put it in the organic nitrogen reserve column. Here, it's all in the organic nitrogen release because I'm assuming that the respiration is good in this sample. And then all together, we add all that up, all those part per million, divide it by two or times it by two, and that's your pounds per acre. So nitrate, ammonium, organic nitrogen together, that's what's available.
Yeah. Yeah. So there's tons,
I ran through that
ton-
really fast. I'm
I
sorry.
know that was good. There's a lot on here. Um, just for your context too, this is the same sample all the way through. So the respiration was that like 90, which is why everything is in the release. Um, okay, so like the overall takeaway for the nitrogen, and when I'm looking at a Haney test and trying to put all of these parameters together, the primary one that I focus on, especially when we're talking about making fertilizer recommendations, is this available nitrogen pounds per acre. And we'll hit on it in a couple slides here on exactly how those recommendations work. We've got a couple people already asking, like, what does that look like? But this available nitrogen pounds per acre is the key parameter to focus on for that. And like Liz said, this available N is taking into account all of these parameters and the biological activity to understand what is actually available to your plant at that time.
Maybe you should go. We only have like 20 minutes left.
I know. Yeah.
Hold on. I'm sorry. But
This
maybe
is
you
the,
should go into the fertility Rex part.
yeah. Let's do phosphorus
I
really
can't
quick.
see the chat. Okay.
Let's do phosphorus really quick, like we just did nitrogen, and then we can talk about fertility, Rex. I'm
Okay.
not surprised that the time is going so fast.
I talked too much.
So,
Um, yeah, so similarly to nitrogen, we measure organic phosphorus as well. And the way that this is done is when, and I'm going to go all labby on when we measure inorganic phosphorus, it's through it used to be, maybe it's not anymore. It used to be through a rapid flow analyzer, and it's colorimetric, and it responds to inorganic phosphorus. But if you run it through a different instrument, which is an ICP, we can see organic and inorganic phosphorus together. And so by difference, we can tell what the organic is. Um, Again, this is going to be acted upon by the microbes and released to the plant. Back to carbon to nitrogen ratios. If you were to look at organic matter as a whole, the generalization is that there's 100 parts carbon, 10 parts nitrogen, and 1 part phosphorus. And so these numbers are typically a little bit lower, the organic phosphorus numbers, but it makes sense when you're considering the structure of organic matter. And then again, we have organic phosphorus reserve. That's if your CO2 numbers are really low, typically below 20, is when they'll put that in the reserve, and then organic phosphorus release. But that all goes towards your available phosphorus.
yeah. Yeah. So it works the same exact way as the nitrogen. When I'm thinking about fertilizer recommendations, I'm focusing on this available P pounds per acre. And same as available N, it's considering all of these forms of phosphorus together with the biological activity so that you can really understand how much phosphorus is in your soil and available to your plant. Okay, so recommendations and kind of the impact of this. This is an example from our CEO Mitchell's farm here in Southeast Iowa. By using the Haney test and focusing on like this nitrogen comparison section, and then the available N, available P, and available K. We haven't talked about available K, but works the same way as available N and P. we've been able to reduce our NP and K fertilizer pretty significantly, and then have also been able to reduce the lime down to zero just by understanding, what things look like in the soil and how the pH is actually influencing everything. So we'll look at really quick here just the nitrogen piece, and I can kind of run through and explain this part, and Liz, jump in wherever you feel is necessary. But the way that conventional nitrogen fertilizer recommendations are going to work is they look at the crop and the yield goal to get the total amount of nutrient needed. And then the only thing that they're taking credit for in the soil is the nitrate. Like we mentioned in the nitrogen section, we're giving you a whole host of parameters. From a standard soil test, if you're lucky, you'll get just nitrate, and that's it. And then they'll take a credit from the past crop, credit from the subsoil, credit from the organic matter, and then the irrigation water if you use irrigation to give you that final recommendation of how much nitrogen is actually needed. With the Haney test, we're doing it a little bit differently. So again, we're looking at the crop and the yield goal to get the total amount of nutrient needed. And then instead of just taking a credit from the nitrate, we're using that available N parameter that I said was kind of the key one to focus on. The available N is looking at nitrate, ammonium, and organic nitrogen. So you're getting a larger credit from the soil because we're looking at all of these pieces and the biology. Then we'll take into account any credits from past crop, subsoil, everything else to give you that final recommendation. So it's pretty simple. It's really just like how much total nitrogen does your crop need based on the yield goal, and then subtracting out this available N and any other credits that you might want to take to get that total amount of nutrient needed to apply.
And I recommend obviously split applications, but if you're growing a cover crop, you can also do a cover crop test to figure out how much of each of these nutrients is available in your cover crop that will be released later over time. Because it's not going to be right there in that snapshot, especially if you're like sampling in early spring.
Right. Yeah. That leads into a good question that Cole asked here. So he said, what is the best time to test for to get the recommendations to be the most accurate? He said, it seems like spring right before application and planting would be the most accurate, but that gets hard logistically to try to get them done, like figure out the recs and actually apply before planting. So how do we recommend he manages that?
And that's going to depend on where you're at, obviously. Because like where I'm at, people start planting corn on Valentine's Day.
Now,
Yeah,
yeah.
it's spring here.
Yeah.
Um, so we have lots of time to do that. But, in the northern climates, I would take it after harvest in the fall. You're probably going to lose some nitrogen over the winter, but you're still going to be able to make better recommendations than if you didn't, take the test at all.
Yeah.
If you're trying to monitor your soil health and how your management practices are impacting your soil health, I would take it in the spring at the same time every year, meaning same temperature, moisture conditions, that kind of thing.
Yeah. I think it kind of depends. I mean, like you said, it kind of depends on your goal most of the time, and also actually when you are trying to apply your nutrients. If you're doing dry P and K in the fall and you're putting all of your nitrogen on in the fall also, um, then pulling a soil sample before you do that in the fall makes the most sense. But if you're doing split application, like Liz mentioned, and you're trying to really dial in that second application to finish things off for the season, then taking the sample in the spring can really make them a lot of sense too. So I would say that most of the growers that we work with are doing spring sampling. It does get kind of hectic to try to get it done by the time the soil is warmed up to 50 degrees. Everyone's calling like, hey, where are you at? When are you going to get here to pull these samples? But usually we can get it turned around pretty quickly. But it does get kind of tight. That is the most
We
accurate
do
timing
apply
though.
nitrogen in the fall.
What's that?
Why would you apply nitrogen in this?
There's a lot of people around here that do just that as anhydrous, but not these great folks on this webinar because they care about soil health. Yeah. Yeah. So Cole, that's kind of I know that was not like a super cut and dry answer for you. It really does depend on like, are you putting nitrogen on with the planter and then you're going to come back and do your second application to get the rest of your in for the season as side dress? Like, what exactly does your fertilizer program look like? But if your goal is to really dial in the nitrogen recs, then I would say springtime is probably the best.
Or do, a moderate pre-plant or plant
Right.
application and then come in 2 or 3 weeks before you side dress. Yeah.
Yeah. Yeah. We have a lot of people that do that too. They'll do a consistent amount of nitrogen on the planter, and then that gives more flexibility to get the samples pulled and the recommendations turned around. So then that side dress rec for, late May, early June is what is actually based on the soil test results and the available N. And that first application with the planter is just like a standard 40 units every time or whatever it might be.
Yeah.
Yeah. Okay, available P and available K and how we use those for fertilizer recommendations. The concept is pretty much exactly the same as nitrogen. So we look at your crop and your yield goal to figure out the total amount of nutrient needed, and then we subtract the available P or available K from that total amount to turn around and tell you how much nutrient needs to be added. So it's super simple. We don't make it complicated around here. This was kind of mentioned a little bit, why to soil test and when. Obviously, this last question hit on it, but I think the key thing on this that you mentioned already, Liz, was the consistency. Can you talk a little bit about that? Like, why would we not want to pull samples in the spring and then pull them again in the fall and try to compare the two? Why is it important to like stay consistent and make sure you understand like what your goals are when you're building a soil testing program?
Yeah. So I think I mentioned it earlier on, soil biology is going to change over time. And that's what the graph actually looks like right there.
Hmm.
So in January, microbes are down here. You're going to have lower respiration. You may not get all the credit for your organic nitrogen. And then as they get more active and stuff like that WEOC's going to build, your WEON's going to build, everything's going to be changing. And so we want to measure, if we're monitoring soil health, we want to measure at a consistent time so you have a trend over time. Because environmental conditions affect nutrient availability, they affect how your plants are performing, how they're feeding the microbes. It's all very interactive. It's not just set in stone. We're extracting the chemistry here. We're looking at biology and which biology changes. And then obviously you want to make sure you have enough time to dial in your fertility program. So when you build something, if you want to look at something year over year, be consistent and not just in the timing of sampling, but also in where you sample. A lot of my growers, and I know Carolyn's, we have points. You go back to year over year over year. They're based on slope elevation, zones, soil type, all of that. And then you can go back to the same spot and you're looking at the same basic soil every year, year over year. And that increases consistency, reduces variability.
Yeah. Yeah, consistency is definitely the most important part. That'll hopefully eliminate too many of the questions of like, why is this number so much different than the last time I pulled this sample?
Yeah.
Okay, we've got a lot of questions here and we're getting close to running out of time. If you have questions, make sure to put them in the Q&A, but we'll run through a bunch of these really quick. So someone asked, how much does Continuum charge to facilitate the Haney test? When we come pull the samples for you, send them to the lab, run the recommendations, sit down and go through the results with you, the whole thing. We charge $12 an acre. Our next slide here has contact information of who you can reach out to if you are interested in that, Sophia is the main point of contact there. Liz Scott asked, are there any other labs where the Haney test is a valid test, or is Regen Ag Lab kind of the only one that runs it the way that you prefer?
A can of worms right there.
I know.
Um, I have looked at results from other laboratories, and um, because I've been looking at results for a very, very long time, I can see where things don't jive. And it's not a personal thing, but the instrumentation might be off, the method might be off. People take their own spin on things. Regen Ag Lab is the only one that runs it according to the published documentation. And in fact, Lance spends a considerable amount of money and time focusing on improving methods and making sure that things are calibrated in the laboratory, and not kind of going off the rails and doing something funky with ratios and blah 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 that don't mean anything. Um, so it's the only lab I use.
Yep. Okay, Mitch asks, and I think we've hit on this quite a bit, but if you could just summarize, does the time of year affect the results? And as it does, like, what do those changes look like? Yeah, how does time of year change what we see?
Yeah. So also going to depend on where you're at. My right microbial respiration may not change that much over time. Um, it's going to change day to day because in Texas it can be winter and then summer and then winter and then summer in a day. But especially if you're in colder environments or dry and arid environments, it the microbes are going to respond to that. I don't think that your like phosphorus levels, your inorganic phosphorus levels are going to change that much, or your K levels are going to change that much. But definitely the organic numbers, the nitrogen numbers, the microbial activity, all of that's going to change. Like I said, I thought that sample that she was showing as a representation had probably been recently fertilized. We can see that. If you go out and sample and there's deer poop on the top of the soil and you get it in there, that's going to change it. Like it's very sensitive to biology. It's very sensitive to time, conditions, and climate. And as scientists, what we want to do is reduce variability as much as possible. Like when we're doing research trials, we especially want to do that. But still be practical for your program. So make it as consistent as you possibly can within your labor and time constraints, and then take everything in context. Everything is in context. It's like text messaging someone. You don't get their vibe or their feel or what they're thinking or their tone. It's a lot harder to interpret that than if you're sitting face to face with someone.
Yeah,
Same thing with soils.
definitely. Okay, Wade is asking, what is our preferred soil test depth? And then can a farmer submit their own samples? Is there a protocol to follow for doing that?
Yeah, so take a 0 to 6 inch sample. That is where the majority of your microbial activity is going to be. We know that roots go further. So if you want to measure like your full fertility, take a 0 to 6 and a 6 to 12 inch sample, but standard is 0 to 6. And then what was the second part?
Just a quick comment on the depth. The 0 to 6 is how we prefer for the
Yeah,
fertilizer recommendations too. Like it just
yeah.
is the most consistent. Okay, and then the second part of the question is, can a farmer submit their own samples? Is there a protocol to follow for doing that?
Yes, yes. And you can find I think there's a protocol on the lab
Yeah,
website. You can submit
yeah,
your own samples. Yeah, it's a free country. Do
yeah.
whatever.
Yeah, if you go to regenaglab.com, they'll have like the different tests and stuff. And I know on there is a page where you can download the sample submittal form. Definitely fill that out fully so that the ladies that do the sample receiving don't call you and yell at you. And on that submittal form, there also is the protocol for how to pull the samples as well.
Yes. And you can ask for fertility recommendations.
Yeah. Yep. If you don't want to go through like trying to understand how to do these recommendations yourself, there is a box you can check, and the lab will give you fertilizer recommendations. Um, I would
Yeah, cash
suggest,
crops and projected yield and all that. But
yeah, yep, yeah, it's all on the submittal form. If you're looking for just like general information and trying to get started and kind of just understand this, I think that's definitely a really good route to dip your toe in and see what things might look like. If you work with us or if you work with Liz, like that's where we can get you more dialed in, like variable rate fertilizer recommendations, more based on like zones within the field. The lab will just give you kind of like a general standard. So it just depends on how, dialed in and aggressive you want to get on it.
yeah. And if you they won't share your results with anybody other than yourself, but if you need interpretation, you can hit either one of us up
Yeah.
for that
Yep.
as well.
We're happy to help. Okay, Darcy's asking if split applying in the spring and waiting for the Haney test, we should probably do a tissue also before the second application. Who does great tissue tests? Should we do sap or tissue? Any thoughts on tissue testing as a
Yeah.
whole and what that looks like?
I would do tissue testing. I think I would go. Oh, I send a lot of people to do the tissue testing through like Waters Laboratory. I think they do a really good job. SAP testing, I have always had a really hard time like interpreting the results, but recently talking to Adam Chappell, who he goes through, which is I can't remember, but if there's a follow up email that we're sending out, then we can send that information that gives him more of an idea how the nutrients are moving through the system. Um, but it is very good to look at the tissue versus what's in the soil because sometimes your soil test numbers might be low, but it's already been taken up by the plant. And every different kind of plant has a different time where they're going to take up nitrogen, where they're going to take up potassium, where they're going to take up micronutrients and stuff like that. So it's all relative to, when you take the sample, you need to know, did I take the sample at, V4, whatever
Yeah.
that might be. Yeah.
Right. Yeah, the timing of the sampling is the most important part for all of that, especially when you're looking at all of it together. We only talked about the Haney test for soil tests today, but that's where things like TND, total nutrient digest, or the PLFA test can come into play as well to just help you understand the bigger picture. This is kind of just the intro to like, here's a soil test that you can use to understand your fertilizer recommendations. But if you're trying to get even more and more dialed in, then SAP and some of these other like tissue tests can help as well. Okay, I think we have time for like one or two more questions. So David is asking, can Liz recommend cover crop mixes based on the test?
I would have a farmer do that for you that is local to your area. Yes. I mean, the answer is yes. We can recommend cover crops based on the test because of the carbon and nitrogen ratio, the percent MAC, respiration, talking with you and your system. Um, but I generally pull in an expert that has actually, because I'm a soil scientist, I'm not a farmer, planted, different cover crops in your area and knows what works in your system. But for
Yeah.
sure, it helps to guide those decisions for sure.
Yeah. Yeah, the way that we make our cover crop recommendations at Continuum is we use, like Liz mentioned, the C to N ratio, the respiration, some of those key things from the Haney test. But then we also have to understand like what is your crop rotation, what is your climate, what are your goals? How willing are you to plant into a really big biomass cover crop? Like there's so many layers to it that you just can't see from the test alone, but the test can really help guide that piece. Um, okay, one really quick one, and then we'll get wrapped up here. So, one last person asked, what's the sampling density for the $12 an acre? When we're charging $12 an acre at Continuum, that's on a 10-acre zone for the samples. So if you've got an 80-acre field, you'll have 8 zones in that field. And the reason we do it at that density is to get the variable rate fertilizer recommendations. If you're looking for a more like just broad understanding of what's going on in your soil, that's where like a 10-acre zone might be pretty aggressive and you can go much, much larger than that. So. Cool. Okay. Well, thank you for all the great, great questions, everybody. Definitely, we need to get wrapped up here. If you have any more questions for either one of us, here's our contact information. Like I mentioned, if you are interested in soil sampling from Continuum, definitely reach out to Sophia. She runs all of that for us. Please make sure that you're signed up for emails from both Soil Region and Continuum Ag. That's where we'll announce any future webinars like this. Last summer, Liz and I did a bunch of Haney Test master classes where we just like really deep dived into this stuff for like 4 hours. I think we're going to do some more of those this summer as well. So make sure you're signed up for our emails so you can see when those are happening and where. But other than that, Liz, thank you so much for joining me
Thank you.
today. This was super fun. Thanks everybody online. And we will see you guys next time. Bye.
Thanks.